This is a random forest, a powerful machine learning algorithm based on decision trees. And this is tennis, a sport I'm kind of obsessed with. In this video, I'll build a random forest, throw at it a bunch of tennis data, and then make it predict tennis match outcomes and predict the winner of a big tennis tournament. And we'll see how it performs. But first, I need data. I want a lot of data. I want every single breakpoint, every single double serve, every single double fault. I want everything. Their backhands, their forehands, their heights, their ages, their dad's name, their mom's name, their grandma's secret lasagna recipe. Yeah, I need that stuff too, man. I'm surviving on noodles over here. And then I found it, the holy grail of tennis datasets. A file so massive, so detailed that opening it crashed my computer, summoned 3 statisticians, and made my Excel beg for mercy. The famous 2008 Wimbledon final between Rafa Nadal and Roger Federer, I got it. The longest Grand Slam final of all time, I got it. Even this one time this kid beat Rafa Nadal and Novak Djokovic back to back, I have it. I have it all. I have every single ATP, Association of Tennis Professionals, match from 1981 to 2024, baby. But before using this data, I want to try building a decision tree from scratch. That's right, no sklearn, no PyTorch, just my good old friend NumPy and me. And decision trees are pretty awesome. Think of them like a choose your own adventure book, but instead of deciding whether you fight a dragon or run away, it's deciding who won a tennis match. Let's take the Titanic disaster as an example. We've got a lot of data on passengers, things like their age, their cabin, and ticket class. A decision tree works by asking a series of yes and no questions to classify whether someone survived. For example, let's take Miss Elizabeth Bonnell. A simple decision tree might start by asking, did she pay more than £20 for her ticket? Yes, she did, so we go left. Next question, was she in first class? Yes again. At this point, our tree confidently predicts that she survived because, well, she actually did. And we can use this tree again and again to predict other passengers. This is really a simple tree, but this is what I got when training with the Titanic dataset. And you might be asking, how do we build this huge tree? Well, this is the coolest part. We don't need any fancy algorithm like with neural nets, no matrix multiplication, no gradient descent, none of that fancy crap, just some logic and some simple arithmetic. Here's how this works. First, we grab all the Titanic data and start with an empty tree. Now, our goal is to find the variable that best splits the passengers into survivors and non-survivors. Turns out that the most powerful first split is passenger class. Alright, so we split the data. First class passengers go one way and everyone else goes this way. But hold up, there's still some impurity. Not everyone in first class survived. So what now? Well, we look for the next best split. And guess what? The strongest predictor now is sex. So we slice the data again and boom, every female in first class survived. That means we have hit a pure node, which we marked as survived. And for the other branches of the tree, we keep repeating this process, finding the best split, dividing the data, and checking purity. Until ta-da-dan, we have ourselves a fully grown, absolutely magnificent decision tree. Woo! Let's go! Implementing this in Python was actually pretty straightforward, but I don't think it's gonna be very fast. Great, so now we have a fully working decision tree classifier. But before we use it to predict the outcome of the tennis matches and gamble some money, we need to clean up the tennis data because it's looking kind of gross. Okay, 10-second cleaning montage. Boom, combine the datasets, remove empty data, get the ranking difference between winner and loser, do this bullshit. Okay, bada bing, bada boom. My beautiful dataset is complete. It has 95,000 tennis matches with their corresponding statistics, and there's a lot of statistics I calculated, let me tell you that. For example, the head-to-head for every match, that is the number of times a player has won or lost against another player. The player's age difference, their height difference, the number of matches won in the last 50 matches, and a bunch of other stats that I won't get into. It's a lot. But before we throw all this stuff to our classifier, we need to plot our data. Plot, 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 plot. So I cooked up a quick SNS pair plot and mwah, I got this beauty. A bunch of variables plotted against each other, showing us some interesting patterns. Of course, some variables are absolutely useless, like player ID, but I want to draw your attention to this one, player ELO, because it seems to be splitting data really well. So let me show you how I calculated this. The ELO rating system is a way to approximate a player's skill level. It's mostly commonly used in chess, but I decided to apply it to my tennis tennis dataset. Let's take Roger Federer as an example. At the start of his career, his ELO rating was around 1500, pretty average, but as he kept winning matches, his rating skyrocketed, eventually becoming one of the greatest players of all time. Now, here's his ELO progression plotted against every tennis player ever. As you can see, he is way up there. And if you're wondering about these two other lines, naturally, those are Rafa Nadal and Novak Djokovic, two other tennis legends. And the cool thing is that ELO is fairly easy to code. Let's take the 2023 Wimbledon final between Carlos Alcaraz and Novak Djokovic. Alcaraz was rated about 2063 and Djokovic was rated about 2120, according of course to my calculations. In a shocking comeback, Alcaraz won the match, which by the way I watched live and it was really cool. And since he won, his rating has to be updated, so we take this handy little formula and calculate his new rating. Turns out Alcaraz gained about 14 points and Djokovic lost about 14 points, so it's pretty easy. Actually, according to my tennis ELO rankings, the current best player in the world is Jannik Sinner, who just won the Australian Open, followed by Novak Djokovic and Carlos Alcaraz. And here's how their ELO has evolved over time. This represents their overall ELO, but in tennis, the surface you're playing with really matters. It's really different playing tennis in clay, grass, or hard surfaces, so I also implemented surface-specific ELO. For example, Rafa Nadal is known as the king of clay. He's won 14 French Opens and has a 112 win versus 4 losses record at the event. The guy is a beast, and as you can see, his clay ELO is really good. In fact, it's the highest I've seen. As a final example, here's how Carlos Alcaraz Grass's ELO has changed after winning back-to-back Wimbledon titles in 2023 and 2024. And tennis ELO turns out to be quite good at predicting who will win. So let's take all this data and fit it into a decision tree to see how well it classifies winners. And while my model is training, I want to thank Brilliant for sponsoring this video. Brilliant is an online learning platform for computer science, science, and maths. They have great courses on everything from calculus and linear algebra all the way up to neural networks. In fact, I have done a lot of stuff behind the scenes that I haven't really shown in the video, like principal component analysis, linear regression, and a bunch more. And while I won't have time to explain it, Brilliant has some fantastic introductory courses on data analysis and probability, where you learn by experimenting with hands-on examples. They make learning fun by giving you puzzles and little games to test your understanding. They even have courses on search engines, cryptocurrencies, quantum computing, how AI works, and loads of other fascinating things. So if you want to support this channel and explore exciting and interesting topics, click the link in the description and use my code GREENCODE for a 30-day free trial and a 20% discount on the annual premium subscription. Seriously, they're awesome, so go check them out. Ooh, okay, our decision tree finished training, and I have some good news and some bad news. Good news is that it gave us a pretty cool looking decision tree. Bad news is that my implementation was really slow, like painfully slow, so I ended up having to use sklearn's version. But for all the haters out there, my code works, okay? I tested it on smaller datasets and it works just as fine. It's not ready to handle 95,000 tennis matches. But anyway, using that classifier out of the box, we get 74% accuracy, which sounds really promising until you realize that simply predicting based on ELO alone gives you 72% accuracy. So yeah, we can do better. To take things to the next level, we need random forests. A single decision tree tends to have high variance, so it's quite sensitive to the specific data it's trained on. But if we create multiple trees, each making its own prediction, we can combine the results through a majority vote and get a more stable and accurate model. Now, building a decision tree is deterministic. That is, if the input stays the same, we'll build exactly the same tree over and over. So the trick to build a random forest is build many trees using different random subsets of the data and different subsets of the variables. This way, there's a little bit of more variation, which makes the model more robust. I also implemented my own random forest from scratch, but guess what? It was too slow for my huge dataset again. But using sklearn, I got 76%. Not bad, not bad. We can even visualize our forest and it looks like this. Pretty sick, right? Now, at this point, things got tricky. I tried to improve my model by running a grid search, tweaking the data, and fine-tuning the random forest parameters. But no matter what I tried, I got stuck at 76-77% accuracy. So I decided to try XGBoost. An XG boost classifier is like a random forest on steroids. It uses boosting, regularization to prevent overfitting, and it keeps trees from growing too large. It's kind of hard to explain in this video, but maybe if you like the video, I could explain it in another one. But you know, up to you. It's right there though, just saying. But anyway, I got a staggering 85% accuracy, baby. Yoo-hoo! And as you can see, the most important features it recognized were ELO surface difference and total ELO, which is pretty cool. Just for fun, I also decided to quickly train a neural net to see how it would do on this data, and I got a decent 83% accuracy. Now, to end this video, I wanted to see if my model could predict the winner of this year's Australian Open. You see, I trained my models with tennis matches up until December 2024, so this year's Australian Open was not in my dataset. And out of the 116 matches I could find, my model correctly predicted 99 of them and got only 17 wrong, and hence has an accuracy of 85% on this year's Australian Open. More importantly, it correctly predicted that Jannik Sinner would win every single one of his matches. So my model correctly predicted the winner of a Grand Slam, which is pretty sick if you ask me. I had a lot of fun with this video, so if you want me to try to predict this year's Wimbledon champion using XG Boost from scratch, like the video and comment potato below. If 50 people comment potato, I guess I'll make a second part. Hope you enjoyed it, and I'll see you in the next one.